Okay, once again, welcome. Continually, we have to look over into the structures that's provided in the AlexNet. Okay, so the first layer of the convolution, and it uses the 96 kernels, and each kernels having the size of 11 by 11, and it's having the stride of 4. In case if you don't know what is the meaning of the stride, and then you may visit with the previous slide, but simply I have to say how the sliding window protocol in networks that works. In the same way, the strides is also working. I have to be assigned certain frame to compute the particular kernels. So that is the simple definition behind that is that stride, and it's having a stride of 4 and that activates them with that ReLU activation function, and it performs that maximum pooling operation. And in that second layer, it takes obviously to get the input from the first layer, and it's having 256 kernel, and each kernel having the size of 5 by 5 into 5 by 5 by 48. And the third layer, it's having a 384 kernels, and it's having 3 by 3 into 256. And this part doesn't have no kind of the pooling or that normalization. This kind of normalization and then pooling, everything be performed in that third and fourth, third or that 4 or 5th layers. So already we know what will happen in that pooling, and then so what will happen in that normalization. And in that 4th layer, we can able to be applied, that is the concepts of the pooling. So there we are applying the max function, and then what will be the max value from the appropriate strides. So the 4th layer having a 384 kernels of size 3 by 3 for 192, and that 5th layer having the 256 kernels of size 3 by 3 for 192. And then we are having the fully connected layers that's implemented by the concept of softmax. And the fully connected layers is having 4096 neurons for each layer. So you have to be multiplied 4096 into 3. So the output layer is already we know that is implemented with a softmax layer that produces the probability of 1000 class tables. So this is the complete detailed architecture of AlexNet. So here you can able to see for that every layer how many of the strides that has been applied, and if there is any padding, the padding is also taken into the consideration. So obviously for that layer 1 we are having the 4 strides, and layer 2 in that max pooling layer we are having the stride of the 2, and then next layer also we are having the 2, and from the layer of 3rd, 4th, 5th we are having that padding layers. So finally we are applying that as a stride after the layer of the 5th implementation of max pooling, and then it has to be come with that fully connected layer. So there it has been segregated with that 4096, 4096, and finally the softmax that has been applied, and it creates 1000 class tables there. So this is the main architecture of the AlexNet, and this is the quick scenario on the dimension details of the ResNet, and what kind of that activation that has been implemented in that every layer. So from all the convolution layers except from that max pooling, we are implementing that is the rectified logic unit, and then fully connected, except that output of that fully connected we implemented that ReLU also, and the last one where it's having that is that softmax. So this is the dimension details for padding and without padding that scenario. So already we know, so what is the concept of that padding. If you are having that certain segregation in that future extraction, in case if I want to segregate that image, I can able to be fix 0 0 0 0 in for that outer layer. So if I am putting that is at 0, so that will easily segregate the image from other boundaries. So this is the term of that padding. So on this AlexNet can able to implement with padding and then so without padding, and this is the formula. So the 227 minus 11, it's talking about that pixel rate of pixel size of that images. And if you are working with that padding, and then we are having the formula of 27 by 27 into 256. So without padding, we are having the formula of 50 by 55 into 96. And here you can able to be find out for that every architecture how these scenarios with the padding and then without the padding are implemented is given. When you give a clear concentration with this every layer there, you can easily understand how this padding are working with that AlexNet. So thank you very much for that viewing.